Hello everybody. Today we are going to solve system of linear equation by graphing method. To solve by graphing method, we have to graph each equation. Then to graph each equation, we have to isolate one variable. Usually in math, we isolate y. Then let's start with the first equation. That is equation A. Then equation A is x minus y equals 2. Then to isolate, then is just leave y in one side of the equations. In this case, I think the easy way is this one. X minus 2 is going to be equals to y. Or we can rewrite y equals x minus 2. That's the first equation. Equation B is x plus y equals to 6. Then to isolate, it's really easy. Y is going to be equals to negative x plus 6. Okay, when we have already each equation isolate the same variable, in this case y, then we have to graph each equation in the same coordinate plane. Let's remember that a solution of a system of two equations is an ordered pair that makes both equations true. By graphing method, all of this solution meaning is just we can conclude that the solution is the intersection point between the equations. Then we can use a number table to find the points, the coordinates, and then plot the points. Then the number table is composed by x and y, and the number table for the second equation exactly the same, x and y. Then this is a line, okay? Then we have to use just at least 2 points or 2 different values for x. It's not necessary to use more. Then I always recommend use the easy one. The easy one is 0 and the other value is 1. Okay? If we know what happened in the function, in the equation in this case, when x value is 0 and what happened when x value is 1. Then let's analyze first 0 for the first equation, equation A. Then what happened? What is the y value if x is 0? Then if x is 0, x is 0, minus 2 is negative 2. Then if x is 0, y is going to be negative 2. Now, what happened when x is equals to 1? X is 1. 1 minus 2 is equals to negative 1. In the second equation, we have to do exactly the same. I recommend you use the easy values, and the easy values are 0 and 1. Now let's analyze for the second equation what happened with y when x is 0. Then if x is 0, is 0 plus 5 is plus 6, sorry, is equals to 6. And what happened if x is 1? If x is 1, then it's negative x. In other words, negative 1 plus 6 is equals to 5. Okay, then in this point, let me show you very quickly that you have to create the coordinate plane. And the coordinate plane is composed by y-axis, that is the vertical, and x-axis, that is the horizontal. Now we have to locate the points. What is 0? 0, of course, is the intersection. This is 1, this is 2, this is 3, and more. Okay, remember that all of the spaces must be equal, otherwise our graphic is not going to be exact. Okay, exactly the same in the y-axis. Now, when you plot the points, it's just use the coordinates. Then, for example, let's plot the first one, 0 and -2. Then we have to locate where is -1 is almost here, and -2 is almost here. Then 0, 0 in the first number table, 0 and -2. 0 is x value and -2 is y value. Then the point is going to be here. Then from through this point, the line is going to go. Okay, we have to draw the line from this point. But we need the second point to graph exactly the linear equation. Then is 1 and -1. 1 in x and -1 in y. Then the point is going to be something for here. Then the line, when you connect the points, you know that the first line is something like this. Okay, of course my representation is not exact, but I'm going to show you the real graphic. Okay, this is the real graphic representation. As I told you, the green linear equation represent my example. Okay, if you plot the points for the number table for the second equation, is going to be the blue one. Now, as I explained from the beginning, the intersection point is the solution. If you are solving system of linear equation by graphing method, then you are looking for the intersection point. As we can see, the intersection point is, remember that always we name the x component first is 4, and the second component is y is 2. Okay, very well. Then that means that our solution is going to be 4 and 2. But of course, we have to remember the definition of the solution of a system of an equation. A solution of a system of two equations, of a system of two equations 2 by 2, is an ordered pair that makes both equations true. Of course, this is the ordered pair. But if we want to check that this ordered pair makes the system of each equation true, we have to check. How can we check? It's really simple. Everything we have to do is replace our order pair in each equation. Okay, remember that the first component is x component and the second component is y component. Okay, then let's check for the first one. A is the original equation is x minus y equals 2. Now let's replace x, according to my solution, is 4. Okay, minus, because it's the original equation, y is 2, according to our order pair. Now this is true. Negative 4 minus 2 is 2. Yes, it's correct. That means that it's correct. It's true for the first equation. Now exactly the same for the second one, and the second one is x plus y equals to 6. One more time, replace exactly the same order pair. Then 4 plus 2 is equals to 6. If this is true, then it's because our solution is correct. And yes, it is.